So what we're looking at today is chapter 1.4, which is modeling with linear functions. So what we're looking at is data given to us, and we're going to write it in a linear form. So y equals mx plus b. Use our slope-intercept formula, or use our point-slope formula. Or if we're given 2 points, we can use it to find the slope and then use point-slope. All of these are just different equations of a line. Now, the way they named them is a little creative. Not so much. Does anybody know why they call it the slope-intercept form of a line? Yes? No? What is m in an equation of a line? M stands for the what? What is the b value here? So what do we have in this? We have the slope in the y-intercept. We have the slope here and the y-intercept here. So we're going to call it the slope-intercept form. Is that really creative? Not really. They're just calling it just what it looks like, isn't it? It's like calling me tall man. We're just identifying what in the heck it is. There's nothing really creative to it. Point slope. X1, Y1 is a point. M is the. So it's just really calling this, hey, it has a slope, and then we have a point here. It's point slope. They have an equation called 2-point slope, or 2-point equation of a line, which essentially is, instead of having slope, they just plug the slope formula in. Nothing really different. It's just they use the slope formula. Instead of saying it's m, they actually plugged it in, our y2 minus y1 over x2 minus x1, the way that we can find the slope. And we call this the 2-point formula. Why? Because we use 2 points to find it. So the overall naming of these isn't all that creative. It's just pretty much exactly what it is. They're naming it just because of the parts. Now, when we look at this here, writing the linear equation from a graph. This graph here, I believe it's on your paper too, yes? This graph here. The graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of a line and interpret the slope. The asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? So here we're looking at distance in miles compared to time in seconds. So at 0 seconds, looking at the graph, at 0 seconds, how far is it traveled? How far is it traveled at 0 seconds? Has it gone anywhere? No. What is the distance? If we look at the graph, at 0 seconds here, well, the distance is still at 0, isn't it? Because when time is 0, the distance is 0. It's at the origin. It's at 0, 0. That's where the graph's at. Now, we can kind of guesstimate at 2 seconds, 4 seconds, but what does it tell us? At 5 seconds, how far has it gone? 24 miles. What do y'all think? Is that pretty fast? That's decently fast. What is Tulsa's about 70 miles from here? So 24, 48. What is that? 48 to 72. So you could travel from here to Tulsa in about 15 seconds, going at that speed. That's pretty darn fast. Because if we could travel that speed, going to Tulsa, let alone California, would take no time at all. So that's how fast it's traveling. Now we want to write an equation for this here. Now we have 3 equations we can use. The first one is our slope-intercept form. And the other equation we have is point slope form. Now, depending on what we're given is going to depend on which equation we use. Do we know the y-intercept? Do we know the value for which this graph crosses the y-axis? Because if we know that, then I'm going to use this equation. If we don't know that, then hopefully we at least know 2 points, or we can see 2 definite points on that equation, on that line, to be able to describe it. Well, what is 0, 0? Isn't that the y-intercept? So I know the y-intercept, yes? The y-intercept, b is 0. The y-intercept, the actual point of the y-intercept is 0, 0. But the y-intercept, our value for it is 0. Now all we need to do is find the what? Slope. We just need to find the slope. So we didn't need this other equation since we know the y-intercept. So slope, m. Let's have a little bit of a refresher with this here. M is equal to what? Rise over, or what? 2 minus y1 over x2 minus x1. Those subnotes, so the 2 and the 1, so we have x2 minus, or so y2 minus y1 on top. What does the 2 and 1 mean? Why do I write that? Why do we have that? What is that for? They're actually not coordinates. It's to distinguish that those two have a value, a specific value, and they are different from each other. It's also telling me that y2 and x2 go together. They're connected. We're talking about y2, y1. Those are 2 different values of y. y1 and x1 are contained, are a part of the same point. They're together. They're connected. So looking at this here, we could use either one of these here. I'm going to show you both. So here's one of our points, yes? So how far do we go up? What is the rise? We go up. And that right there is our slope. Now, can we reduce 24 over 5? Is 5 reducible? Can I write 5 as a product of 2 numbers? No, 5 is prime, isn't it? And the reason I'm asking that is it's trying to see, is there a common factor here? Is there any way to reduce 24 over 5 down to something smaller? Like if we had 8 over 6, that can reduce. Is it reducible is what we're wanting to find. And it turns out 24 over 5 will not reduce. (24 over 5 will not reduce. So that's our slope. Now what we did there is we just used rise over run. We counted up and went over to the first spot that hit us, kind of whole number mark. Now the other thing we can do is we can use the equation y2 minus y1 over x2 minus x1. So what I can do is our y2 and x2, I'm going to use the point 24 and 5. 24 for y, 5 for x. Now where's another point on this graph that we know for sure? There's only one that I can see. 0, 0. 0, 0 would be the other point. And for this problem here, it doesn't do a whole lot. It doesn't really show us much. Because what's 24 minus 0? What is 5 minus 0? It gives us the same thing. The only way this would be different is if the point wasn't 0, 0, then we would see it work out. Now we should get the same thing as this, doing the rise over run, as we would for this here. It is the same thing. It's talking about the same animal. Erase this here. So now we just need our equation. So y is equal to what? 24 over 5 plus 0. So 24 over 5x plus 0. Well, if I add 0 to anything, does it change? So it's the same as 24 over 5x. So we did the first part of this equation, this problem, because it has to write an equation of the line. We did that, yes? Interpret the slope. So the slope is what? 24 over 5, yes? What is that telling me? That for every what? 24? Or we can say what? For every 5 seconds, 24 miles, it's traveled 24 miles, yes? For every 5 seconds that have passed, it has traveled 24 miles. Or it's traveling 24 miles in every 5 seconds. Interpreting the slope, what is it telling us? What do we know about the slope of the line? And that's what it's asking for. It's just, what is the slope telling us? Every 5 seconds, it's traveling 24 miles. Or it's traveling 24 miles in 5 seconds. And that's it. About how long does it take the asteroid to travel that distance? 17,200. So we're wanting to know about the time, yes? Is x or y in this equation? Which one of those would be time? Is x time or is y time? Look at the graph. It's x. Because when we look at the graph, it tells us time is on the x-axis, y is the distance, yes? For every 5 seconds, it's traveling 24 miles. So if x is 5, these would cancel out, wouldn't they? Let me actually write that out. So if we plug 5 in for x, because what did we say about this here? For every 5 seconds, it travels how far? 24 miles. What is 24 over 5 times 5? Well, the 5 and 5 here do what? Cancel out, which leaves us with y is equal to. So again, I wrote this out because, again, it's reiterating what we said, wasn't it? That for every 24 miles is traveled every 5 seconds. So when x is 5, we got y as 24. Is that what we expected to get? Yes. So now we're wanting to know how long it's going to take to travel 17,200 miles. So where would I plug 17,200 into our equation? Would I plug it in for x or y? It would be y. Because our y value is our distance. Because this whole thing is set up in time is our x, because we're saying after how many seconds. So after 5 seconds, we went how far? 24 miles. So if we want to know how long it takes to go 17,200 miles, we have to plug it in for y. So to get our answer here, we have to solve for x. So what would be our first step in solving this for x? We need to get x by itself, yes? So what's connected with x? Or what's with x? 20 over 4 over 5. Now, how do I reduce this? How do I get rid of the 24 over 5? There's more than one way to do it. What do y'all think? What's the operation between 24 over 5 and x? By? I wouldn't divide by 17,200 because we're wanting to get x by itself. Well, what's it with x? Well, 24 over 5, isn't it? Because are those two being multiplied together? Yeah, we can undo multiplication with division. I can divide it by 24 over 5 because anything divided by itself cancels out. So over here, we're dividing by 24 over 5. So on this side here, we get x by itself. 17,200 divided by 24 over 5. At this point here, we can plug this into a calculator. The calculator will do this. Now, if you're having to type this at home, I mean, what we can do is we can type it as 17,200 divided by parentheses 24 over 5. Or we can do 17,200 divided by parentheses 20, that's supposed to be a 4, 24 divided by 5, and close parentheses, because those parentheses is telling that calculator we're doing the 24 divided by 5 first, and then divide it by the 17,200. So it keeps it separated. Because using the parentheses will help keep everything straight. And what our answer will be 3,583 and 1/3, or 0.3 repeated. So 3,583 and 1/3 seconds will be the time it takes for this asteroid to travel 17,200 miles. And that's it. So this asteroid, that there is very close to 1 hour. 1 hour is 3,600 seconds. So it took it almost 1 hour to travel 17,200 miles. I can't remember off the top of my head, but I have a feeling this is actually greater than the circumference of the Earth. So it'll go all the way around the world in almost an hour. So any questions on this so far? Is this bringing back a decent bit of just Algebra 1 stuff? Yes? And that's what it is. But we're using data. We're looking at data here. So looking at this next one here, the graph shows the remaining balance Y on a car loan after making X monthly payments. Write equation of a line and interpret the slope and Y-intercept. What is the remaining balance after 36 payments? Does this graph look realistic for a car loan payments on a car loan? Does this look realistic? Should the graph look like this? Does it look like it should be going down? Well, I hope so. I really hope that if you have a car payment or took out a car loan or a loan of any type, that the balance is decreasing. It better be decreasing. Especially, I'm going to put this out there. Have y'all seen a commercial for furniture at any point in your life? Yes? You can buy this whole set of furniture at 0% interest for 72 months, yes? Just be looking at the next time you see that. Have your finger on the pause button, and there should be some subtext about this big at the bottom. Pause it and read it. And if I remember correctly, at the end of that 72 months, if you have not paid it, you will get charged 29.5% interest off the original balance. So again, it's a great deal if you can do it, if you make sure you pay it before then. But if you don't, you will get charged almost 30% of what you originally spent in interest. And it'll start compounding fast. And the reason I say that with all of this here, with any type of loan, interest will kill you faster than anything else. So what you really want to do is have it planned, paid out. It should be decreasing. It should be going down. You want to pay those things off. And there are some things in life, and car is one in particular, house, furniture on a maybe, but those in particular, you're going to have to pay it with a loan, most likely. But I don't know about y'all, but I do not have $15,000 or $20,000 to just drop on a car, let alone, I think the average price inside loan is somewhere around $200,000 to drop on a house. If it's where my parents live, it's close to, I think the average home's around $800,000 for a home. California is even worse. Northern California, San Francisco in particular, a plot of land, I mean, it looks like Siloam's Little Acres. You've seen those little plots, they're small. $500,000, or not $500,000, 1.5 plus $1 million home. And it's not bigger than a double wide. I mean, you don't get the overall square, it might be 2 stories, but I don't think you get more square footage in this room. They have apartments that are less, or about the square footage of this room here, and you're paying over $3,000 a month. Nope, ain't gonna do it. So again, there's some things we just can't pay straight out of our pocket, so we have to take a loan. So we look at this loan, we want to write an equation. So do I know the y-intercept for this here? Do we know the y-intercept on this equation? What's 0, 18? 0, 18 is the y-intercept, yes? So we can use y equals mx plus b. And we know our value of b is 18. Now, because of the scale, are they going every single one of those little blocks? If we go down 1, is that worth 1? Is the distance from 18 to this next line, is that a distance of 1? No, because if it was, somehow they managed to go down 2 and get to 12. So it's not. Now, we can go through the calculations and try to figure out what the distance for one of those is, and then do the calculations for the other side. Or, am I given 2 points? Yeah, if I'm given 2 points, let's skip that and just go to our slope formula. y2 minus y1 over x2 minus x1. So what is our y2 value? 18. Which means our x2 value would be 0. The y2 or y1 values really don't matter. We just got to pick one. So we picked 18 as y2, so y1 is going to be 15. Which means our x1 is going to be 10. Now, once you pick a y2 value, it's set on what the x2 value is, because they have to go together. x2, y2, y1, x1, they have to be together. They have to be in the same order, because if we flip it, it's going to give us the wrong slope. If we flip those, we get the wrong slope. Now we just need to simplify. What is 18 minus 15? 3. 0 minus 10. So our slope is negative 3 over 10. Can we reduce 3 over 10 at all? No, that's as simplified as it gets. So we have our slope and y-intercept. So can I write the equation of the line? Yes. Now hopefully at this point you've got the slope, this part written down. If not, if you're watching the video, you can always back it up. But I think we're good with the slope. Yes. So when we write our equation, we'd have what? Y equals negative 3 over 10x plus 18. So that's our equation of a line. And interpret the slope and y-intercept. So our slope is telling us what? So for every 10 payments, what's happening? We're going down 3. We are paying off how much? Is it just 3? Are we paying off $3 every 10 months? What are we paying off? 3 what? Thousands. Because again, it kind of hit it over here, but the balance is in thousands of dollars. So for every 10 payments, we're paying off $3,000. Every paying off $3,000. For every 10 payments, we're paying off $3,000. So that's our slope, interpreting the slope, because every 10 payments, we're paying off $3,000. We're able to pay off $3,000 every 10 payments. Now, what does the y-intercept tell me? The starting balance. The starting balance. So if the starting balance was 18, it started off at how much? $18,000. It started off at $18,000. And most likely, the actual value of the car is not $18,000 because you have to barter. You need to barter. Do not pay sticker price for any car. But then you also have a down payment. Down payments are very helpful. It actually gets you a better interest rate. So most likely, the car that you bought is not worth, the sticker price is not $18,000. So we got this here, and we interpreted the y-intercept. Y-intercept was our original payment. Now the last part of this is, what is the remaining balance after 36 payments? So what are we wanting to know? After 36 payments, what is left? Well, how much do we owe left? Do you think it's going to be less than 0? Let's look at the graph. Is the graph less than 0 at 36? Well, I can't exactly pick out 36. It's somewhere in here. It's definitely above. So what do we need to do? Well, I just need to plug 36 into y, yes? To find the remaining balance? So we plug 36 into y? No, because x. Because y is telling us how much is left. X is how many payments we've made. So what we do is we plug in 36 for x. Can we plug all of this here, all of this right here into a calculator? Yeah. At this point here, we could plug negative 3 over 10 times 36 plus 18 into a calculator. We can plug all that in. Because it's all the numbers. We have all numbers on that one side. So actually, negative 3 over 10 times 36 plus 18. What it'll tell us is that we have 7.2. All of this here will bring down to 7.2. And again, this is in what? Thousands, yes? So what they told us is after 36 payments, we have how much left on the car? How much do we owe? $7,200. Is this a good thing? Yeah, I mean, we have less than we owed, right? Well, how long have we owned this car? 36, so 12 months in a year. So you normally make one payment a month. So that's what? 3 years, yes? At this rate, we will have that much left in 3 years. I have a feeling at 60 is their plan to pay it off. Pay it off in 5 years. Overall, that's not a bad plan. That's not a terrible plan. But it's not a great plan. I will tell you that straight up. That is not a great plan. The average, I think, cost of a Honda Civic is about $26,000 in 2009. It's more than that now. It's in like the 40s. I have had that car since 2007. So, and they bought it in my parents bought it in 06. So that's 14 years. I looked this up the other day. How many do you think that I could sell my car for right now after 14 years? And this is not to a dealership. Do you have a guess? Started out at 26,000. Just take a guess. There's no wrong or right answer. What do you think? $3,000. It is worth $3,000 right now. But what that tells you, and what I'm trying to prove or kind of show you with that there, is that price has dropped decently, yes? It has lost $23,000 at least. So in 10 years, let's just say 10 years instead of 14, so we don't have that, well, I have a calculator right here. On 23,000 divided by 14. It is losing $1,600, so $1,642.86 a year in value. So in the course of, say, 6 years, it will have dropped $9,857.14. 1,000 minus. So it was close to $16,000 after 6 years. Now, the reason I point this out and make this emphasis is if I'm not paid this off, especially for this year, and it's losing $1,000 a year, in 10 years, or not 10 years, so $1,000 a year, after 3 years, it's dropped down $3,000, so it's not bad. But if whatever the car or the house or whatever it is worth is less than what you owe, it is called being upside down. Being upside down is the worst place you could ever possibly be. Do you know why? Okay, and I'm going to use this as an example, all right? You don't have to do anything. So Caden bought a car for $18,000. He's making payments on it. After 7 years, he's paid off $9,000. So he's halfway done. But they go and he estimates the worth of it, and they say the car's worth is $6,000. He owes $9,000 on the loan. The car's worth $6,000. We got a $3,000 difference, yes? And he sells it. I come up and I pay $6,000 for the car. What is he out? $3,000. That loan does not go away. He now has $3,000 worth of interest still left, or amount left on that loan, that he is now what? Paying for a vehicle that he does not own. Paying for a car is kind of bad. I mean, it hurts paying these loans, after you have a loan trying to pay it. Think about paying a loan or paying for something you don't even own anymore because you had to get rid of it. That sucks, yes? That's why being upside down, if you've ever heard of someone being upside down on a loan, That is what they're talking about. They owe more than it's worth. So even if they sold it, they would still have to be paying for it after it's gone. So that's why, especially for car loans, if you have the ability to pay them off, pay them off. Even this year, so $3,000 a month, or $3,000 after 10 payments, that sounds pretty high, doesn't it? Let's look at that number again. So it's every 10 payments we're paying off $3,000, yes? So can anybody tell me how much one payment is? Well, we would divide it 3,000 by what? 10. What is 3,000 divided by 10? $300. So $300 a month. Well, how many days are in a month? 30, yes? So if I divide 300 by 30, what do I get? $10. So if I saved $10 each day, so instead of going and getting McDonald's for 10 bucks, I saved it, I can make a $300 payment, can't I? And then I can do this here. Does that make sense? And one of the best ways, especially that I think, if you're trying to, again, this is just thinking in the future. This isn't something that's going to happen now.